Hi everyone, welcome to this channel. Today we present the solution to NECO Physics Theory 2023. If you are not subscribed to the channel, do well and subscribe. How do you subscribe? Go to the channel's name, Best Science Brain. Under the channel's name, you see a small bell with a subscription written on it. Tap on it and get subscribed so they can see our videos as soon as we load them. So let's look at this question. NECO 3. We're going to start with part 2 of the theory. Because part 2 is where the mark lies. Question says, answer any 4 questions from this part. All questions carry equal marks. Number 13A I says, state Newton's third law of motion. Solution. Newton's third law states that for every action, there is an equal and opposite reaction. For every action, there is an equal and opposite reaction. 13AII says, explain the recoil of a gun using the stated law. So we have to explain the recoil of a gun using the Newton's third law of motion. Solution. When a gun fires a bullet, the gun puts a force on the bullet that propels it forward. The bullet likewise exerts an equal and opposing force on the gun in the reverse direction. We take the solution once more. When a gun fires a bullet, the gun puts a force on the bullet that propels it forward. The bullet likewise exerts an equal and opposing force on the gun in the reverse direction. 13B says, mention 2 advantages of alcohol over mercury as a thermometric substance. 2 advantages of alcohol over mercury as a thermometric substance. Solution. Alcohol has a lower freezing point than mercury and can be used in thermometers that can measure very low temperature. Number 2, alcohol has a greater value of temperature coefficient of expansion than a mercury thermometer. Number 13C, a 0.5 kilogram copper calorimeter with a thermal capacity of 195 joule per Kelvin contains 0.3 kg of water at 27 degrees Celsius, a metal of mass 0.2 kg at a temperature of 100 degrees Celsius was gently dropped into the calorimeter and the mixture was well stirred. Calculate the final temperature of the mixture, neglecting heat losses to the surroundings. Specific heat capacity of water is 4,200 joule per kilogram per Kelvin. Specific heat capacity of metal is 460 joule per kilogram per Kelvin. We now have the solution to number 13C. We have divided the solution into 3 columns: copper calorimeter, water, and metal. Mass of the calorimeter is 0.5 kg, as you can see there. Then CP means the heat capacity or the thermal capacity, and CP is mass times specific, which is 195 joule per kilogram. The initial temperature of the calorimeter is 27 degrees Celsius. Then water mass is 0.3 kg. Its initial temperature is 27 degrees because the water and calorimeter are together, so they will have the same initial temperature. Then the specific capacity of water, CW, is 4,200 joule per kilogram per Kelvin. Going to the metal, the mass is 0.2 kg. Initial temperature is 100 degree. Then its speed capacity is cm 460 joule per kilogram per Kelvin. Then we now say let the final temperature of the mixture, which you're looking for, be called theta. Now calculate heat loss by metal using MC change in temperature, which is 0.2 times 460 times 100 minus theta. Open the bracket, we're going to have 9,200 minus 92 theta. They will now go to heat gain by copper calorimeter and water. That becomes MC, that means mass of calorimeter times CC, speed capacity of calorimeter times change in temperature, plus mass of water times speed capacity of water, that is CW, times change in temperature. Then making our sub, okay, MC is the mass calorimeter times CC, speed capacity will now give us CP, because that CP is, as we said before, that CP is the mass times speed capacity, that is, we call the heat capacity of calorimeter. So replace MCCC by CP. Then change temperature, giving us MWCW times change in temperature. Making our substitution 195 into theta minus 27 plus 0.3 times 4200 times theta minus 27. Open the bracket, we have 19H equal to 195 theta minus 5265 plus 1260 theta minus 34020 34020. Then collecting like terms, we have H equal to 1455 theta minus 39285. Then we now equate, okay, solving that the expression H equal to 195 theta minus 5265 plus 1260 theta minus 34020. Collecting like terms, we now have H equal to 1455 theta minus 39285. How do we get 1455 theta? 1455 theta is nothing but 195 theta plus 1260 theta. That gives you 1455 theta. How do we get minus 39285? Going to above expression, minus 5265 minus 34020 give us minus 39285. So this expression here represents the total heat gain by metal and calorimeter. We now move to the principle of heat capacity, which is heat loss equal to heat gain. Heat loss by metal is 9200 minus 92 theta. We bring it down. Then heat gain, of course, heat gain is gained by calorimeter and water, is 1455 theta minus 39285. We equate the two. Then collect items. We have 9200 plus 39285 equal to 1455 theta plus 92 theta. Collecting items together and then solving out. 9200 plus 39285 give us 48485. While 1455 theta plus 92 theta give us 1547 theta. Then making theta the subject, we now have 48485 all over 1547, and dividing, we have 31.3 degrees Celsius as our final temperature of the mixture, or final equilibrium temperature of the mixture. Number 15A says, how can an uncharged body be positively charged by induction? How can an uncharged body be positively charged by induction? Solution: a positively charged body is placed close to the uncharged body, thus causing all the negatively charged particles of the uncharged body to move towards the end, closer to the charged body. We'll come again. A positively charged body is placed close to the uncharged body, thus causing all the negatively charged particles of the uncharged body to move towards the end, closer to the charged body. 15b says sketch the magnetic field pattern around a current carrying solenoid. Sketch the magnetic field pattern around a current carrying solenoid. So this is the field pattern around a current carrying solenoid. As you can see, the battery and the switch. You can see the coiled solenoid, and then we can see the lines passing through the straight lines passing through the solenoid. These lines represent the magnetic field. Then the north pole is the side or the region through the lines of force are leaving the field. Then the south pole is the point where the lines of force are entering the field. You can see the magnetic field lines drawn accurately. That is it. Look at question 15c. Says use the circuit diagram below to answer the question that follow. We have two circuit diagram. Fig 1. In Fig 1 you can see two resistors in parallel to 2 ohms each, connected to another 2 ohm resistor in series. Then down there you see a battery. You see battery, each of EMF 1.5 volts each, connected in series, and then internal resistance of 0.1 ohm each. Then that is Fig 1. Then Fig 2, we can see also a circuit again, but this time around we have an alternating circuit. We have a 2 ohm resistor connected to a coil or an inductor, 2 Henry inductor, and then a capacitor of 2 microfarad. You can see alternating voltage 240 volts, frequency 50 Hz. That is Fig 2. So that the diagram drawn for 15c. So look at the questions that follow. The first question says identify the two circuits. Solution to 15ci. Identify the two circuits. Fig 1 is direct current circuit, while Fig 2 is RLC alternating current circuit. R means resistor, L means inductor, C means capacitor. Alternating current circuit. Then going to 15c triple I says calculate the current in the circuit in Fig 1. Calculate the current in the circuit in Fig 1. Here we have Fig 1. As we say, two resistors are in parallel, the 2 ohm facing each other. Then we have another resistor 2 ohm in series. They will have the batteries down 1.5 ohm each, internal resistance 0.1 each. We have to find the current in Fig 1, this figure. So let's go to the solution. So first of all, we'll find the resistor, total resistance of resistors in parallel. We can use a shortcut. RP stands for resistors in parallel. There are two of them in parallel, as we said. We can use the shortcut. We say R1 times R2 all over R1 plus R2 instead of taking the LCM. We use product all over sum. So 2 times 2 all over 2 plus 2, that gives us 1 ohm. Then we'll now find the total resistance. 1 plus 2 giving us 3 ohm. So that 1 is the net or the sum of the two in parallel, as we have it here. While 2, the value 2 represents the resistor that is in series. So as you can see, these two are in parallel. When combined, give us 1 ohms. 1 ohm plus then these two giving us 3 ohm. So that's how we got the 3 ohm there. Then total battery EMF is 1.5 plus 1.8 giving us 3 volts since they're in series. Then total internal resistance 0.1 plus 0.1 giving us 0.2 ohms. Current is given by I equal to E all over big R plus small r. Our EMF is 3. Then our total external resistance is 3 ohms. Then our internal resistance R is 0.2. Then solving 3 over 3.2, we have a final answer is 0.938 amperes as current flow in the circuit. Then 15 IV, we have to calculate the impedance in the circuit. In Fig 2, impedance in Fig 2, given that the values of the capacitive and inductive reactances are 227.3 ohms and 628.6 ohms respectively. So how the 15C IV, the impedance is represented using Z. The formula is square root of R square plus bracket opens SC minus SL all square, where SC represent the capacitive reactance and SL represent the inductive reactance. Then we now go to the calculation in the circuit. Arrow is in Fig 2, R is 2 ohms, so to arrow with 2, and then the value of SC and SL are already given to us in the equation, that the capacitor and the inductive reactance. We now substitute them and then square and solve out. When we solve this, we now have 4 plus 16104.1.69. Solving out, we have adding 4 to that value, we have 16104.5.69. Then find the square root, we have 401.3 ohm as our impedance. 401.3 ohm as the impedance. Number 16A says, why is it difficult to wash an oil plate with water only? Reason, water molecules are more attracted to themselves than they are to oil. The force of cohesion between water molecules is greater than that of adhesion between water and oil. Question 16AII. Why are oil and grease used as lubricants? Solution. They are liquids of high viscosity. 16A triple I. Distinguish between cohesion and adhesion. Solution. Cohesion is the intermolecular force of attraction which exists between molecules of the same kind. Example, molecules of water. Adhesion is the intermolecular force of attraction which exists between molecules of different kinds. Example, molecules of water and glass. 16B. A sample of radioactive element with a half-life of 6 days has an initial mass of 250 grams. I. Obtain the values for the masses of the element remaining after 6, 12, 18, and 24 days. I plot a decay curve of the element using the values obtained in BI above. Solution to 16BI. We take the half-life, the symbol lambda represent half-life, which is 6 days. Then MI, the initial mass present, which is 250 grams. So how do we find the mass remaining after 6 days, 12 days, and 18 days, 24 days? We'll go on. At the end of 6 days, we now have 250 over 2. That gives us 125 gram remaining, or remains. At the end of 12 days, we have 125 over 2. That gives us 62.5 gram of the substance remains. At the end of 18 days, we have 62.5 over 2 again. That gives us that 1.25 grams of the substance remains. At the end of 24 days, we have that 1.25 over 2. That gives us 15.625 gram remains. So that answers question number 16B, which says obtain the values for the mass of the element that remains after 16, 12, 18, and 24 days. We go to number II. Plot a decay curve of the element using the values obtained in BI above. So for the graph, we are plotting the mass remaining. After 6 days, we have 125 gram. After 12 days, we have 62.5 above. After 18 days, we have 31.25. After 24 days, we have 15.625 as calculated in the AI part of this question. So what we are plotting is mass remaining against time, that is days. So you can choose a scale of maybe 2 cm, 2 cm to 20 units, 20, 40, 60, 80, 100, 120, 140 continuous. Then you can now choose on the day time axis. You can choose 5, 10, 15, 20 per house, 25 per house, 2 cm to 5 unit. You plot your graph, you're going to get a shape of this nature. The plotting should be done on a graph booklet, not on a paper. On a graph booklet, taking the readings and then plotting it, you're going to have a graph that has this shape. We shall now quickly go through some questions in section A, part 1 of the theory, where you have small, little marks. Part 1, the first one is says mention 2 devices that intercept solar radiation for heating purpose. Solution: you can use the solar thermal collector and then the flat plate collector. These devices can intercept solar energy for heating purpose only. Solar thermal collector and flat plate collector. 1B says sketch a multi-stage rocket and label any 2 parts. So solution: have the rocket sketched, have the head pairing of rocket, have the second stage, we have the first stage launch vehicle. So that is sketch of a multi-stage rocket. That answers question 1. Still on question 1, 1C says a compound microscope has a magnifying power of 10. If the magnification of the objective lens is 2, calculate the magnification of the eyepiece. We go straight to equation. Magnifying power of a compound microscope is given by MO times ME, where M is magnifying power, which is 10. MO is the magnification of the objective lens, which is 2, and ME is that of the eyepiece, which you are looking for. So making ME the subject, we have M over MO, divide 10 by 2, we have 5. So 5 is the answer for the magnifying power of the eyepiece. So go to number 2. Before we go to number 2, we should know that number 1 is compulsory. So compulsory for all students. Number 2, it says, what is static friction? Solution: is the frictional force between 2 bodies or surfaces when they are not in motion. The frictional force between 2 bodies or 2 surfaces when they are not in motion, or you can say it is the maximum force that must be overcome before a body would slide over another. Going to 2B, a block of wood of weight 5 Newton is pulled by a spring balance which indicated a horizontal force of 5 Newton just before it moved. Calculate the coefficient of static friction. Solution: the weight of the wood. The weight is equivalent to the normal reaction, which is 5 Newton. The force pulling it, since it was at rest, the force pulling it is equivalent to the static frictional force, which is 3 Newton. So using the formula, coefficient of friction given as force of a normal reaction is going to be 3 over 5, which is 0.60. No unit. Number 4A, what is the velocity ratio of a machine? Solution: velocity ratio is defined as the ratio of the distance moved by the effort to the distance moved by the load from the fulcrum. 4b says distinguish between scalar and distinguish between second and third order levers. Solution: a second lever has the load located between the fulcrum and the effort, while a third lever has the effort located between the fulcrum and the load. Number 5a. State one similarity between heat and temperature. Solution: both are scalar quantities. 5b. A bimetallic strip made of two metals, S and Y, is heated uniformly over a period of time. Sketch a label diagram of the strip after heating. Linear expansivity of S is equal to 1.51 power minus 5 per Kelvin. Linear expansivity of Y is equal to 1.82 times power minus 5 per Kelvin. Solution: when the strip is heated, you're going to curve. So the question is, which of them will curve more? Is it S or Y? Y will curve more. Y will be inside of the strip. Indicate that Y will curve more because Y has a greater linear expansivity than S. So Y will be inside of the curve, while S will be outside of the curve. Number 7. A ray of light is incident on a rectangular glass block at an angle of 60 degrees. Determine its angle of refraction. Speed of light in air is 3.0 to the power 8 meters per second. Then speed of light in glass is 2.0 to the power 8 meters per second. Going to the solution, the angle of incidence is 60 degrees, I 60, angle of refraction is unknown, V a mean velocity or speed of light in air, which is given to us there, and Vg means speed of light in glass. So try index, which is that symbol, n equal to sine I over sine r equal to the same as velocity in air over velocity in glass. Making a substitution, sine I, that is sine 60, since I is 60 degrees, all over sine r equal to speed of light in air, all over speed of light in glass. Then 10 to the power 8 cancel each other, and they will cross multiply and make sine r the subject. Sine r now becomes 2 times sine 60 all over 3. And sine 60 is 0.8660. So that becomes 2 times 0.8660 all over 3. Solving out, sine r becomes 0.5773. Then how do we find r? R now becomes sine inverse of 0.5773. That will give us 35.1 degrees approximately. That's our answer. Number 9a. What is reactance? Solution: this is the opposition to the flow of alternating current offered by a capacitor or an inductor. Offered by a capacitor or an inductor. 9b. Calculate the frequency at which a 5 microfarad capacitor will have a reactance of 3000 ohm. Take pi as 3.14. Solution: capacity reactance SC given by 1 over 2 pi FC. Then making F the subject, F now becomes 1 over 2 pi C then times SC. Then we know that 1 is centered as 10 to the power 0 if you want to work in indices, all over 2 pi C then SC. Then making our SC is 3000, I will use the capacity reactance, and then our C capacitance is 5 microfarad. Convert to SI unit, which is 5 times power minus 6 farad. Then if you substitute the value of F, all the values, put them into the formula we have over there, substitute the values, and then solve for your frequency. We'll have this, and then finally F will give us 10.6 ohms. 10.6 hertz, 10.6 hertz as our frequency. Number 10a. What are photoelectrons? These are electrons ejected from a metallic surface when light or radiations of a certain frequency falls on the metal. 10b. A metal has a work function of 3.5 electron volt. Calculate its ratio frequency, and we're given the Planck constant 6.6 per minus 34 joules second, 1 electron volt as 1.6 per minus 19 joules. Going to the solution, work function is given by Planck constant h times FO, S subscript O, where FO is the threshold frequency. Making FO the subject, will have F equal to W with the work function over Planck constant. Then making substitution, our W is 3.5, then times 1.6 per minus 19. So we can convert the electron volt to joules all over 6.6 per minus 34. Solving this, we have our threshold frequency as approximately 8.50 times 10 to the power 14 Hz. 11a. Give two head hazards of X-rays. Solution: X-ray can cause damage of body cells or damage to the body cells and leukemia. 2. High doses of X-ray can cause gene mutations and death. 11b. Distinguish between soft and hard X-rays. Solution: so we have a table there. Soft X-ray produced when a low potential difference is placed between the anode and cathode. Under hard X-ray produced when a high potential difference is placed between the anode and cathode of an X-ray tube. The second difference, under soft X-ray has low penetrating power. Then hard X-ray has high penetrating power. The third difference, soft X-ray has longer wavelength and shorter frequency, while hard X-ray has shorter wavelength but longer frequency. So we have come to the end of the solution for NECO 2023 physics examination. Always subscribe and stay tuned to this channel. To subscribe, hit the subscription button and under the name of the channel, tap on the subscription button once and get subscribed. Tap on it once and get subscribed. Thank you.